Hey everyone, I just wanted to go through this review paper with you guys since we have a quiz tomorrow on exponent rules. This paper is pretty close to what you're going to see as far as what a quiz will look like tomorrow. Today, I give you guys a little bit more practice stuff just to kind of mess with. But I wanted to put a video out there to go over this so that if you guys had any questions on how I got my answers that you didn't get, at least this would make sense. And then if you need to, hop on office hours today, that's a really great idea since we have a quiz tomorrow. And if you just want to ask questions, feel free to email me or send a remind, and I can totally get back to you on how I got those things, all right? So the first one, we had c cubed to the second power times negative 3c to the fifth all squared. All right, so the first thing I'm always going to do is power to a power if I have those parentheses, right, with an exponent on the outside. So remember, we're going to multiply when we do that. So that's going to be c to the sixth. Over here, don't forget that when we do power to power, there's a 1 on this 3. Anything that doesn't have an exponent there, we need to write a 1 on. So it's going to be negative 3 to the second, c to the 10th. And then our c's have the same base. So we can keep the base and add the exponent since we're multiplying. So that's c to the 16th. And then we'll just leave negative 3 squared c to the 16th. Now some of you might have had 9 c to the 16th. Remember, you don't have to, all we're doing is simplifying here. You don't have to solve what that exponent is on the number, on like the coefficient, if you will. So we can just leave it negative 3 squared and we're good there. All right? All right, second one, let's see. It's kind of annoying, I gotta write them down every time, but that's okay. You can, 2, 3, 4. And we are multiplying this time. So again, when we multiply numbers with the same base, we can add the exponents, keep the base, add the exponents. So our a's are the same. Keep the a, 2 plus 3 is 5. Our b's are the same. Keep the b, 3 plus 4 is 7. Our c's are the same. Keep the c, 4 plus 2 is 6. And 5 and 6, when we multiply those together, we multiply them because they don't have the same base, so we do whatever the problem says, and that's how we're going to get 30 for that one. So 30, a to the 5th, b to the 7th, c to the 6th. Awesome. On number 3, we had another power to a power, but you got to be careful because there's a fraction here. So we had negative 3/4 c cubed all to the 5th. So when the exponent on the outside, remember, it goes to all of the exponents on the inside. So there's a 3 here, there's a 1 on the 3, there's a 1 on the 4. So this 5 is going to go to all the stuff. Doesn't matter if it's on the top or the bottom. So it's going to be negative 3 to the 5th. Remember, it's not 5 times negative 3, it's 5 times the exponent. 4 to the 5th. And then c to the 15th. And again, I'm just going to leave that just like that. If I wanted to simplify it, I probably would have to figure out what negative 3 to the 5th is, what 4 to the 5th is, and go from there. See if that fraction simplifies. But for here, that's kind of all we want to do. All right? Number 4, same idea with power to a power. Make sure it goes to both the things on the inside. So we have h to the 3rd p, and that's all to the 4th. So don't forget, there's a 1 on this p. 4 times 3, 4 times 1. That gives us h to the 12th, p to the 4th. Just like so. Nice. Oh no. Thought my worksheet was gonna, my Chromebook almost turned off here. There we go. All right, number 5. Number 5 is another multiplication problem. So again, if we're multiplying numbers with the same base, we're going to keep the base, we're going to add the exponents. So So in this one we have x's, we have y's, we have z's. They all have the same base. So we are going to keep the base. Remember there's really a 1 here if you don't see anything, so 1 plus 4 is x to the 5th. Same thing with y's. 5 plus 6 is going to be 11. And 3 plus 3 is going to give us z to the 6th. And the 10 and the 3 don't have the same base, so we just do whatever the problem says. And that means multiply in this case. And that is 30 again. So 30, x to the 5th, y to the 11th, z squared. Excellent. Number 6, moving right along. We have a to the 5th, b to the 7th, and that's all to the 4th. So again, we have our exponent on the outside. We're going to multiply it by all the exponents on the inside. That's going to be a to the 20th, b to the 28th. Pretty straightforward. Nice. Number 7, we have multiple exponents. So we have 6 to the 4th, all to the 2nd, all to the 8th. So if I have multiple exponents, remember I'm going to work outside in. So I'm going to do 8 times 2, and that is, of course, 16. And then I'm going to do 16 times 4, and that's going to give me 6 to the 64th. And there's my simplified version. Number 8 will probably be like the hardest one on your quiz, because we got some multiple rules and one of those things we have to simplify that a lot of people struggle with. So let me write this one down. All that to the 3rd times 4 km to the 4th all squared. All right. Excellent. All right, so here we got power to a power, right? So 3, don't forget the 5. Don't forget the 5. I know you want to. All right, there's really 1 there. Multiply this 3 by all those exponents. So 5 to the 3rd, k to the 6th, m to the 3rd. On this side, don't forget, there's really 1s on the 4 and the k. So it's going to be 4 to the 2nd, k to the 2nd, m to the 8th. All right, so there's that. And then we can use our multiplication rule. So now I see that k's have the same base. Keep the k, 6 plus 2 is 8. M's have the same base. 3 plus 8 is 11. And then how do I multiply 4 to the 2nd and 5 to the 3rd? They don't have the same base, so I can't add their exponents together. So to multiply those, I'm going to have to just figure out what they are. So 5 times 5 times 5 is 125. 4 times 4 is 16. And then when I do 16, now I can do 125 times 16, right? And 12, 15, 16. Do a little magic. And you can see that we get 2,000. So that is the part that people are going to mess up on their quiz tomorrow. You cannot do 20 to the 5th, for example. That's not 2,000. Okay, so be very careful with that one. Because, yeah, I've seen plenty of mistakes there with this 2,000. All right, let's go to number 9. This was number 8, I think. Let me check Aruski. Let's see. All right, number 9, we have 1 over x to the 3rd, all to the 8th. So this 8, again, is going to go to all the exponents. Don't forget there's really a 1 up here, like so. So it's going to be 1 to the 8th over x to 24th. And remember, we haven't got there yet, but we will on the back side of this paper, that if any of these had negative exponents, I would obviously be fixing them, making them into fractions. All right, number 10. All right, number 10, we do have multiplication, and I have some numbers with the same base. So the x's, remember there's really a 1 here. 3 plus 1 is x to the 4th. We have y's, 9 plus 3 is y to the 12th. And then we only have one z, so remember, if it's in our problem and it can't simplify, we just throw it on. All right, we still have 10 z's in there. And then 7 and negative 3, we're going to multiply those because that's what the problem says. They don't have the same base, which is negative 21. And then I'm going to ask you, do I have to move negative 21 to the bottom because it's negative? No. Only if it has a negative exponent. So the fact that it's negative 21 is okay. We leave it alone because it's to the first power. If it was to the negative anything power, then we would have to move it. All right. On to the back side of the paper. We have x cubed, y to the 9th, over x to the 21st, y to the 2nd, all to the 0. So looking at this one, you're probably thinking, all right, we can do power to a power, and the 0 is going to get multiplied by all this stuff, and 0 times anything is 0, right? And then we have division rule that says you keep the base, you subtract the exponent, but 0 minus 0 is 0, and 0 minus 0 is still 0. And then you remember what we talked about, and that anything to the 0 power is really just 1. So this is really just 1 times 1. And 1 times 1 is just 1. And we could have probably done that right from the rip because all this stuff was to the 0 power. And we know if anything's to the 0 power, it's always going to equal 1. Not the exponent 1, the actual number 1. Okay? So this is all just going to equal 1 because it's to the 0 power. Cool. Number 12. Number 12. Let's see what we got. This thing's freaking out on me. All right. Number 12, we have division rule. So division rule, just like we did, says that if you have numbers with the same base, and we're dividing those things, we subtract their exponents, top minus bottom. So our c's, we keep the c. 4 minus 2, we have 2 c's. Our d's, we would keep the d. 4 minus 4 is 0. And anything in the 0 power is 1. So if you want, you have choices. You can just write 1 in front, because it's weird to write 1 in the middle. We don't do that. Or you just don't have to write anything at all, because you know that if there's no number in front of c, that's really a 1. We do not write d. If you wrote d in your answer, that means d to the first. And there's no d's left. It'd be d to the 0. And I also don't want you to write d to the 0 because we know that that equals 1. So if you wanted to write it and then on the next one just write c squared f to the 3rd, that would be okay. Or if you want to write 1 c squared f to the 3rd, that would be okay too. All right, 13, we have some negative exponents finally. So we know that negative exponents we need to make into a fraction. It does not mean that they're negative answers. But we do have to make some fractions. So here's what I have. I don't have any multiplication, division rule, power to a power. The last thing I always fix is negative exponents. So think of this as a fraction. Y is a negative exponent. It's going to move. I got to move it to make it positive. So it's on the top. We'll move it to the bottom. Z's on the top. We'll move it to the bottom. X is fine where it's at because it's already positive. When I move y to the bottom, it becomes positive 7. When I move z to the bottom, it becomes positive 9. Like so. Awesome. 14. 14, a lot of people in class had trouble dividing. So we had negative 4, w to the 12th, over 12, w to the 3rd. So first off, we have division rule. Keep the base. Subtract the exponents, that's going to be w to the 9th. And then negative 4 and 12 do not have the same base, so we're just going to divide them because it's a division problem. The problem is when I divide negative 4 divided by 12, I get some decimal. And what you'll find out is that Mr. Odie doesn't want decimals in pretty much any problems that we do in class. There's going to be some specific examples of Like scientific notation has a decimal that we're going to talk about a little bit later this week. But if we're simplifying, think of this as just a fraction, right? Division is just a fraction. Instead of dividing and writing a decimal, I can write that, keep it as a fraction. So does 4 over 12 simplify? You bet. 4 goes into both. So 4 goes into 4 one time. 4 goes into 12 3 times. So that would probably be a better answer. Negative 1/3 w to the 9th. And again, I don't have to worry about moving the negative 1/3 because it's negative, because its exponent is positive. All right, 15. Again, it kind of looks like it's going to be division rule, but none of the numbers have the same base, right? So it's not division rule, not multiplication, not power to a power. The only thing I can check for is, does it have negative exponents I want to fix? Yeah, this y, it has a negative exponent, I need to move it. So it's on the top, I'll move to the bottom. Everything else is okay where it's at because their exponents are positive. So this is going to stay, this is going to stay, this is going to stay, y is going to move to the bottom, and when I move it, its exponent becomes positive. That's all you got to do there for number 15. All right, number 16, we have some more division rule. So we got x to the 8th, y to the 3rd, x to the 6th, y to the 11th. All right, our division rule says we keep the base, we subtract the exponents. Keep the base, 8 minus 6 is 2. Keep the base, 3 minus 11 is negative 8. Awesome. So then I'm done. Hold the brakes, right? Because there's a negative exponent in our answer. We can't leave it like that. There's a rule in math. So I need to move it. It's on the top. We'll move it to the bottom. X is going to stay where it's at because it's already positive. So my final answer is going to be x to the 2nd over y to the 8th. Cool. 4 more to go. All right, we got z to the negative 4th over a to the negative 3rd, b to the negative 9th. Lots of negatives in this one. But again, I'm not going to check that till the end. So any multiplication, division rule, nothing, no parentheses, no power to a power. So all I got to do is fix my negative exponents. So this one, it's negative, I got to move it to the bottom. This one's negative, a, it's already on the bottom, so I'm going to move it to the top. Same thing with b, already negative, it's on the bottom, we move it to the top. So the a will move to the top, become positive. The b will move to the top, become positive. The z will move to the bottom and also become positive. Woo! 18. I see parentheses, that makes me think power to a power. So let's see what we got going on in 18. It looks like it's all to the negative 4th. So the very first thing we'll do is multiply that exponent through, like distributive property, right? So 7, 1 times negative 4 is negative 4. X, 3 times negative 4 is negative 12. Awesome. So that's power to a power. Check, is there any negative exponents? There sure is. So this is going to have to flip. This will move to the bottom. This will move to the top. And my final answer will be x to the 12th over 7 to the 4th. Very good. 2 left. Number 19. Looks like straight up division rule. So we got r to the 4th, t to the 7th, v cubed over r, t to the 4th, v to the 5th. So when we're dividing, remember we're going to subtract our exponents. Don't forget there's always a 1 there if you don't see anything. So we keep the r, 4 minus 1 is r to the 3rd. Keep the t, 7 minus 4 is t to the 3rd. Keep the v, 3 minus 5 is negative 2. And then at the end, again, I see a negative exponent. I got to fix that. So I want to move v to the bottom. That's going to give me r to the 3rd, t to the 3rd over v to the 2nd. Awesome. And the very last one, we have x over 7 all to the 9th. Don't forget that that 9 is going to go to everything on the inside. So there's really a 1 here, there's really a 1 here. Multiply by both, and that gives us x to the 9th over 7 to the 9th. So that's the review worksheet. Now there is one more thing I wanted to talk to you about. I have seen ones like this on a map or an air test before, where it'll say something like 3 to the 3rd times 3 squared to the 5th all over 3 to the 6th. And it will say something like, what are all the things that are equivalent to this? Select all. One of those select all ones. So typically what you'll see is there's a lot of different steps, right? So for example, here, first I would multiply through, and that would give me 3 to the 3rd, and that would be 3 to the 10th, right? 5 times 2. So maybe that is a choice. I would select that one because it's equal to that. It's equivalent. But then also I have multiplication rule up here. So they're both 3's. 3 plus 10 is 13. So maybe that's a choice. Right? 3 to the 13th over 3 to the 6th. That is also equivalent. It's part of me simplifying it. And then of course I can use division rule here and do 13 minus 6 and get 3 to the 7th. And that's definitely a choice too. So basically what it is just making sure that you show all of your steps and then seeing, all right, was this a choice? Was this a choice? Was this a choice? As I'm simplifying it, is it this thing? Another way to check this is put it in your calculator. Am I getting the same answer for whatever they said, for whatever 3 to the 7th is? If so, those are probably equivalent things. And you can usually use your rules to figure out how that's true in reverse. All right, quiz tomorrow. Make sure you ask questions if you're not understanding anything, all right? Have a great Monday.